Hello everybody. For this video lesson, we're going to be taking a look at a very important, almost critical piece of understanding if you're going to be looking into statistics and probability, and it's called Bayes' theorem. So let's look at a situation where Bayes' theorem might help us to understand a little bit more about the world. Suppose that as a part of a routine physical, your doctor administers a test for a certain type of allergy. He tells you that this particular test is 98% accurate. When the results come back, you find that your results on the allergy test were positive. So, what is the probability that you have that particular allergy? Now, if you're like most of the population, if you're like most doctors, in fact, you're going to say it's 98%. After all, the test is 98% accurate. If I got a positive result, doesn't that mean that the probability is that it's a 98% chance that I have this particular allergy? What we're going to find out is that Bayes' theorem tells us that we are wrong. We're pretty far off, actually, at 98%. And this is something, like I said, a lot of doctors don't actually understand. There was a really interesting TED Talk by a man named Peter Donnelly. It's called How Juries Are Fooled by Statistics, if you want to go and look it up. And he talks about how juries and doctors and police officers and lawyers are fooled by statistics because they don't have a critical understanding of something called Bayes' theorem. So, what is Bayes' theorem? How does it apply? Why do people get it so wrong when they look at situations like what I just showed you? Well, what we need to understand is that the question being asked in that example is, what is the probability of an allergy being present given that we received a positive test result? What is the probability that an allergy is present given that we've received a positive test result? And a lot of people think it's 98% because that 98% accuracy jumps out at them. But what a lot of people are thinking of is this. What's the probability that I got a positive test result given that I have the allergy, that allergy is present in my body, right? That 98%, is it referring to what is the probability that the allergy is present given I got a positive test result? Or is it referring to the probability that I got a positive test result given that the allergy is present? And there's a big difference there. You can see these two expressions are talking about really two different things. The top one is the probability that the allergy is actually there. The bottom one is the probability that we get a positive test result. And so the real question is, which of those two things is that 98% accuracy claim referring to? Is it referring to 98% chance that you got a positive test result because you have the allergy? Or a 98% chance that you have the allergy because you got a positive test result? What is that 98% actually referring to? Well, to really give a mathematically correct answer to that question, you need to understand something called Bayes' theorem. And to be honest, you need more information. You need more information than just knowing that the test is 98% accurate. So let's look at that. First of all, Bayes' theorem gets its name from a guy who was around a couple hundred years ago. His name was Thomas Bayes. He was a statistician, he was a philosopher, he was a minister, and he came up with this formula that helps us to describe the probability of an event if we know some information about some other conditions related to the event. And if you're really starting to get into how Bayes' theorem was derived and how it can be proven, that can be a little bit complicated. The important part is what the theorem actually says. So it looks like this, and it looks maybe a little bit confusing, a little bit daunting at first, but let's break it down for a second. The first part of it, the part that it's giving us, is the probability of event A happening given that event B has already happened. So the probability of A happening given that B has already happened. That is equal to the probability of event A happening regardless of any other conditions, regardless of anything, just in a vacuum if you want to think of it that. What's the probability that event A has happened? That is going to be multiplied times the probability that event B has happened given that we know event A has happened. So a little bit of a conditional probability here. The probability that event B has happened given we know A has happened. Now we're going to multiply these two things together, and then we're going to divide it by the probability of event B happening regardless of other conditions. So in other words, kind of in a vacuum, what's the probability that event B will happen? And if you do all that, you do that little bit of calculation. Again, it looks confusing, but it's just a few simple calculations. You do that, and it's going to give you the answer that you're looking for, the probability of a certain event happening, given that something else has already happened. So back to our original question. What are these events A and B that we'd be talking about in Bayes' theorem? Well, if we're trying to find the probability that we have an allergy after we get a positive test result, what we're looking for, again, in other words, we want to know what's the probability of having an allergy given that we got a positive test result. Then event A, which is the first part of this, is the presence of the allergy, right? This is the A right here. So the probability of or the event A that we're talking about in this example question is the presence of the allergy. Event B, which is the back half of this conditional probability that Bayes' theorem helps us find out, event B is the probability that you get a positive test result, right? So event A, presence of the allergy, event B, positive test result. Well, what we do know, based on the way the question is set up, is we know that the test gives a positive result for 98% of the people that have the allergy. So in the Bayes' theorem, since B is getting a positive test result and event A is having the allergy, that 98%, which refers to the probability of getting a positive result if you have the allergy, that's the probability of B given A, right? So that appears on the top of that fraction in Bayes' theorem, the probability of getting a positive result given that you have the allergy. So what is it that we're missing then? If we want to use Bayes' theorem for this original question that I asked at the beginning of the video, what do we still need to know? Well, we still need to know the probability of event A, meaning we need to know the probability of having the allergy regardless of whether you've been tested for it or not. What's the probability that you have the allergy? What's the popularity, if you want to think of it, of the allergy? And we would also need to know the probability of event B, which is representing, again, the probability of getting a positive test result, whether or not you've had the allergy. Some people might say, well, why would I get a positive test result if I don't have the allergy? And of course, the reason is because these tests are not infallible. They're not perfect. They have a measure of error in them. And specifically, you can get a positive test result without actually having the allergy. And that's called a false positive. So the additional information that we need in order to solve this question is we need to know the following pieces of information. We need to know that the test is giving a false positive at a rate of 5%, meaning that if you give this test to everybody in the world, 5% of the people that don't actually have the allergy are still going to get a positive result. It's going to get it wrong for 5% of the people that don't have the allergy. You also need to know that the allergy itself is fairly rare. It only affects 3% of the population, let's say. So with those two pieces of information, does that give us everything that we need? Well, yes and no. Because we now know the probability of having the allergy. We now know P parentheses A. It's 3%. 3% of the population has the allergy. So we're going to use the decimal version of that. We're going to be using 0.03. We know now the probability of event A. We still don't actually know the probability of event B. We don't know the probability of getting a positive test result. But we should be able to do a little bit of math and figure that out. So let's take a look and let's think about this for a second. In order to find the probability of a random person getting a positive test result from this particular allergy test, we need to consider both the people that have the allergy, that 3% of the population, and we also need to consider the people who don't have the allergy. So, because some of those, like we talked about, some of those are going to get positive results. The test is going to be wrong for some of those people, right? So 97% of the population that don't have the allergy, some of them will still get a positive result. So what is it we need to think about? We need to think that if you get a positive test result, it's either because you have the allergy and the test was right, or you do not have the allergy and the test gave a false positive. Now, this "or" here is in capital letters, it's bold, it's underlined, and that's for a reason. Some of you might be realizing why I'm trying to draw your attention to that. We'll come back to that in a second. So there's these two situations that could result in a positive. So let's think about it. What percent of the population will have the allergy and will get a positive test result? Well, the percent of the population that has the allergy is 0.03 or 3%. Now we're going to multiply that, because of this word and here, we're going to multiply that by the accuracy of the test. 98% of the people that have the allergy will get a positive result. So that gives us this number, 0.0294. But there's another situation that might occur. You might not have the allergy, but get a false positive. So we got to consider that too. Now, what percent of the people don't have the allergy? That's 97%. What percentage of those are going to get a false positive? 5%. So if we multiply those two numbers together, it gives us 0.0485. That's the other group of people that will get a positive result. Since the positive result can be obtained through one or the other situation that I just described, what are we going to do with those two numbers? And of course, this is why that or was I was drawing your attention to that word or, because we know that when we see or in a probability question, we add some things together. So the probability of getting a positive result would be equal to 0.0294, which is the percentage of the people who are going to get a positive result because they have the allergy, plus the 0.0485, which is the people that will get a positive result that's wrong. It's a false positive result. And that means that the total probability of getting a positive result is 0.0779, or almost 8%. So now we have everything that we need in this to put into this spot and this spot and this spot in Bayes' theorem to figure what's the probability that you have an allergy given that you got a positive result. Now, it might be easier with those A's and B's. For some people, you might find it a little bit easier to change them into some descriptor that makes a little bit more sense. So I did it like this. I changed the event A into allergy, and B I changed into R plus for a positive test result. If this helps you, use it. If not, feel free to ignore it. So, you have everything you need. I want you to pause the video now, work out the calculations with Bayes' theorem, and see if you can come up with an answer to the question. What's your probability of having an allergy based upon getting a positive result on this 98% accurate test? Okay, so let's look at how you should have done this. You would have taken the 0.03, which is the 3% of the population that has the allergy, multiplied it by the 0.98, or the accuracy of the test, the probability of getting a positive result given that you have the allergy. Then divided that by that number that we calculated for the probability of getting a positive result, period. And what you should have ended up with was about 0.377, which would actually round up about 38% if I had done my rounding correctly. But regardless, it's around 37 or 38%. So that's a lot less than that 98% that a lot of people are going to think, right? That's the key to Bayes' theorem. Understanding Bayes' theorem can really help you maybe hopefully avoid some of these really kind of drastic errors that a lot of people, very smart people, mathematicians and doctors, a lot of these people make these mistakes. And so now hopefully you can kind of understand how that happens and maybe avoid that. Now, if you're in my actual class, you're going to have some guided notes that are going to have a couple example problems. Let's take a look at those real quick. In example 1, we have a high school where 60% of the boys play football, 36% play ice hockey. And if we know that 40% of the football players also play ice hockey, can we figure out what percent of the ice hockey players also play football? So we're going to use Bayes' theorem. Go ahead and pause it right now. See if you can work this out. Then hit play and I'll show you the solution. Okay, so this is what you should have gotten. The probability of event A, well, event A is playing football. That's given to us at 60%. Event B is playing ice hockey. That's 36%. The probability of B given A is the probability that you play ice hockey given that you are a football player. Problem gives us that at 40%. And what we're looking for is the probability of A given B, meaning you play football given that you play ice hockey. So you plug those numbers into Bayes' theorem, and this is what you come up with. About a 67% chance that you play ice hockey and football, or that given that you play ice hockey, you also play football. Here's example 2. It's similar to the allergy problem that we worked on for the majority of this video. So go ahead and pause this video, see if you can solve it. Okay, these are the numbers that you should have been using in Bayes' theorem. This is what your solution should look like. I'm about out of time, so I hope you understand Bayes' theorem a little bit more now, and I hope you understand a little bit more about how the world works, and you can avoid making some pretty drastic errors based on your now your understanding of Bayes' theorem. Have a great day.